All right, let's get into it. Today, we're talking about the philosophy behind one of the most important books ever written for software developers, Clean Code by Robert C. Martin, or Uncle Bob. And look, this isn't just about code that, works. It's about professionalism, it's about craftsmanship, and it's about writing code that other people can actually understand. So the book kicks off with this really powerful question, and I want to ask it to you right now. Just look at these two doors. You've got one that's well made, it's clear, it's easy to open, and the other one, well, it's a total mess. So be honest with yourself. Which door represents the code you write? The code base your team lives in every day. Are we walking into a clean, well-lit workshop, or are we prying open a cluttered closet that we're afraid is going to fall on top of us? I mean, we've all done it, right? You make a little mess, a quick hack to get a feature out the door, and you tell yourself, oh, I'll go back and clean it up later. But here's the cold, hard truth, something called LeBlanc's Law. Later equals never. That temporary fix, it just became a permanent part of your architecture. And that gets us to our first big point. This isn't just about code being ugly. A mess has a real cost, a huge and often completely hidden cost to the entire business. Think about it like a tangled ball of yarn. When it's new, adding another string is easy. But over time, the code becomes this giant collection of tangles and twists and knots. And now every single feature, every tiny bug fix, means you have to untangle this whole mess in your head. And every change you make, it breaks 2 or 3 other things you didn't even know were connected. You're not moving forward anymore. You're just fighting the mess you created. And this chart from the book just nails it. It's a productivity death spiral. As the mess in the code goes up over time, productivity just plummets, getting closer and closer to zero. And what happens then? Well, management sees things slowing down, so they throw more people at the project. But the new folks don't understand the original design, they're under pressure, and you know what they do? They make more of a mess, which just makes the whole thing grind to a halt even faster. So, who's to blame for this? The book makes a pretty bold claim. It's our fault. The developers. While managers are defending the schedule and the requirements, it is our professional duty to defend the code's quality with that exact same passion. Saying, my boss made me do it is just not an excuse for shipping a mess. And this brings us to the real heart of Clean Code's philosophy. It's a mindset shift. You're not just a coder. You're not just typing instructions for a computer. You are an author, and you have a deep responsibility to your readers. Get this. The ratio of time we spend reading code versus writing new code is well over 10 to 1. Think about it. Before you can write a single new line, you are constantly scrolling around, trying to understand everything that's already there. So if you want to go fast, if you actually want to be productive, you have to make your code incredibly easy to read. I love this quote because it changes everything. Your code is not for the compiler. It's a message in a bottle for other human beings. Those humans are your teammates. They're your future self 6 months from now, and they will judge your work. Will they find it helpful and clear, or will they be cursing your name at 2 a.m.? So if you're an author, your code should feel like a story. It should have a narrative. It sets the stage, it introduces the different pieces, and it leads the reader down a path to that aha moment, where the solution just feels obvious and natural. Okay, so this all sounds great, but how do we actually do it? Well, the book goes deep on this, but let's just focus on 2 of the absolute basics, using great names and writing small, focused functions. This is the classic example. On the left, you've got int d. What's d? No idea. You need that comment to explain it. And here's a key rule from the book. If a name needs a comment, the name has failed. The one on the right, elapsed time in days, tells you everything you need to know, all by itself. No comment needed. Okay. Now look at this function, get them. Get what? What is them? And what is this list of integer arrays? What does the number 4 mean? The code might work, but it's a complete mystery. You have to put on your detective hat just to figure out what it's trying to do. And now, look at the after. It's the exact same logic. Nothing has changed except the names. But now, with getFlagged cells, GameBoard, and isFlagged, the code explains itself. It communicates its purpose. That is the incredible power of just using good names. This leads us to the golden rule for functions. Say it with me. Functions should do one thing, they should do it well, and they should do it only. Your function isn't a junk drawer for random operations. It has one single job. That's what makes it easy to understand, easy to test, and easy to use somewhere else.
And the way you achieve that is with what the book calls the step-down rule. Basically, your high-level functions should read like a series of simple steps, like a to-do list. And each of those steps is just a call to another function that's one level of detail lower. It creates this beautiful top-down narrative, almost like reading a newspaper headline, then the opening paragraph, then the fine-grained details.
Now, you might be thinking, okay, renaming all my variables and breaking out my functions sounds great, but it also sounds terrifying. And you're right. How can we do all this cleanup with confidence? The answer is simple: a solid suite of automated tests. They are the safety net that makes clean code possible.
And this is so crucial. The main reason for tests isn't just finding bugs. Their real value is that they enable change. When you have good test coverage, you have the freedom, the courage to improve your code's design. You know that if you accidentally break something, a test will scream at you immediately. Without tests, your code just gets frozen in place because everyone is too scared to touch it.
So what makes a good test? The book gives us this awesome acronym, FIRST. Your tests need to be fast, so you'll actually run them all the time. They have to be independent, so one failure doesn't cause 100 more. Repeatable, so they work on your machine, your coworker's machine, anywhere. Self-validating, meaning they just say pass or fail, no interpretation needed. And timely, written right alongside the code they're supposed to test. Okay, so we've got our testing safety net. We know how to name things and write small functions. How do we put this all together day after day? Well, it all boils down to one simple, incredibly powerful rule. The book borrows this idea directly from the founder of the Boy Scouts. And it's not about these massive, heroic refactoring efforts. It's about a continuous, everyday process of care. That's it. That's the whole rule. If you open a file to fix a bug or add a new feature, just find one small thing to improve. Rename a confusing variable, break out one tiny function, add a clarifying comment. If everyone on the team does this just a little bit every single day, the codebase won't just stop getting worse. It will actively, consistently get better over time. And that brings us right back to where we started. Your code is telling a story, whether you mean for it to or not. So what is it? Is it a clear, compelling story that guides the next person who reads it? Or is it a confusing, tangled mess that leads them down a path of frustration? The choice is yours. After all, you are the author.